about equivalent fractions, okay? Equivalent fractions are two or more fractions that name the same amount. Equivalent fractions are two or more fractions that name the same amount. Before we begin our lesson, let's review what a fraction is. A fraction is a number that names a part of a whole or a part of a group. You had homework last night where you had to identify the shaded amount that was shaded on the fraction. Okay, who can raise their hand and tell me, in order for there to be a fraction, what is a fraction made up of?
A numerator and denominator.
A numerator and a denominator, okay? A fraction is made up of a numerator and a denominator, okay? What does the numerator tell us? Shelby?
The number of parts that are taken out of the fraction.
The numerator tells us the number of parts that are taken out of the fraction or the number of parts that are shaded in the fraction, okay? What other part is a fraction made of? Come on. Who can help out? Jamarion?
The denominator.
Alright, the denominator. What does the denominator tell us? Axel?
How many parts there are?
Very good. The denominator tells us how many equal parts there are in a whole or in a group. So a fraction is made up of a numerator and a denominator. Which number is the top number of a fraction? What is the top number of a fraction called? Takaya? Very good. The numerator. I'm just going to put N here. The numerator is the top number of the fraction, which tells us how many parts are taken away, shaded, or considered. Okay? What is the bottom of the fraction? Tiana? Very good. The denominator, I'm just going to put a D here, which represents what?
Denominator.
What does the denominator tell us?
How many parts are there?
Very good. How many parts there are? How many what?
Equal parts.
Equal parts there are. Very good. In a fraction, there has to be equal parts. What does equal mean?
The same amount.
Very good, Shanira. Equal means that the same amount. They're the same size. So when you hear the word equivalent fraction, equivalent, what's the key word that you hear in equivalent? Look at this word. What other word do you hear in equivalent? When you think of equivalent, what do you think about? Imani?
Fraction.
Okay, think about a fraction. Shelby?
Equal.
Equal. Very good. Equal. So an equivalent fraction has an equal amount. It's two or more fractions that name the same amount. So today we're going to learn about equivalent fractions. Okay? But let's review real quick. On your homework last night, you had to identify fractions parts that were shaded. If we look at this fraction right here, Brian, what part of this fraction is shaded? Two. Half. Look at it. How many parts of the fraction? How many parts are there in this fraction? No. How many parts are there in this model? 3. Very good. And how many parts are shaded?
2.
So what fraction is shaded?
2.
How many parts are there?
2/3.
Very good. 2/3. There are 3 parts. Very good job. Okay, Davian, let's look at this model. How much of that model is shaded? 3.
3/4.
Very good. 3/4. Okay. What does the 4 represent, Zanarias?
Denominator.
Very good. The denominator. And what does the denominator tell us, Riley?
How many pieces there are?
Very good. How many pieces there are? How many parts there are? We count. We have 1, 2, 3, 4 parts. Very good job. Okay, so I'm gonna give you a piece of paper to use as a model. to be equivalent, it has to equal the what? Same what? Amount. It has to equal the same amount. Want to pass it around? Okay, we're going to use this sheet of paper as a model. Alright, everybody put hold your paper in your hand. Okay, I want you to take your paper, watch me, and I want you to fold it evenly. That means that your ends are touching each other when you fold it. First of all, before we do that, this piece of paper, look at it. Don't open your paper yet. Looking at this piece of paper, does it have any parts in it?
No.
This piece of paper is a what?
A blank. A hole.
A whole. Very good. This is one whole sheet of paper. Okay? We're going to take this whole sheet of paper and we're going to put it in equal parts. Okay? Everybody folded their paper?
Yes, ma'am.
Remember, we started out with one what?
One
One whole. No parts were in it. It was a whole sheet of paper. Open your paper. Now, what has changed about the paper? Axel?
It turned into one half.
No.
It turned into two holes.
It turned into two what?
Hole.
Not a whole.
Half.
Two what?
Part.
Two parts. Very good job, Takaya. It turned into two parts. We started off with one whole. Now we have a paper, the whole that has how many parts?
Two.
That has two parts. Okay? Now what I want you to do. Is I want you to take this colored pencil and I want you to shade one half of the paper. You ain't have to color it neatly. Just take your colored pencil and just shade one half of it. Have it done, hold it up. And put your colored pencil down. Okay, put your colored pencil down and hold your paper up. Okay, now we took the paper from being one whole, turned it into two parts. What part of your paper is shaded?
One half.
All right, very good. One half of this paper is shaded. So I'm draw the whole paper, and I'm gonna put it so you can see it. Put it in half. Then I'm gonna shade half. So one half of the paper is shaded. Okay, now fold your paper back together. Watch me. Okay, now I want you to fold it again. Watch how I fold my paper. Fold it over again. Add it like this. Fold it like this. Horizontal. Go down vertical. Yes. Make sure it is even. Because a fraction has to have equal parts. Now, open your paper. What changed about the paper?
It went to 4 parts.
Very good. Now we have 4 parts. Good job, okay? Now we have 4 parts of the paper. Went from half, went from a whole to a half. Now we have 4 parts. Did the size of the paper change? No, still start on that one whole paper we had. Only thing changed was the parts of the paper. Are they equal? Yes. And once I fold it, so now, how many parts of the paper are shaded? 2. 2. 4. You have 2 that are shaded, and we have 4 parts. So 2/4 of the paper is shaded. Did the size of the paper change? No. What changed?
The
The parts. Okay. So is 1/2 equal to 2/4? Yes, 1/2 is equal to 2/4. We started off with a half. How did we change? How did we go from a half to 2/4?
We folded into 4 parts.
We folded it into 4 parts. All we did was made the parts smaller. We folded it into 4 parts. But the size of the paper did not change. So we generated a fraction that is equivalent to 1/2 by making the parts what?
Equal.
Not equal. The parts are equal, but how did we go from a half, from 2 parts to 4 parts?
From part.
Sakaya?
From part.
From what? From folding it, but what happened to the parts?
They got bigger. They changed. They get smaller.
Very good. The parts got smaller. So they're equal, just the parts got smaller. Okay? So let's fold it back again. Fold it back up. Let's fold it one more time. Take it and fold it over one more time. Fold it over. Everybody has it folded. When you have it folded, hold it like this. Hold it like this. Up in the air so I can see that you have it folded. Raising your hand, who can tell me, what do you think is going to happen to the paper now? David?
Parts gonna get smaller.
You think the parts are going to get smaller? Anybody else? Jamaria?
The part will change.
The number of parts is going to change? Okay. Shaneria?
I thought it gonna be 2/8.
You think that it's going to be 2/8? Okay. What's going to be 2/8?
The part
The parts that are what?
shade.
The parts that are shaded. Okay, that's it. Damien said the parts is going to change. Jamarion says we're going to have more parts. Shaneria said she thinks that 2/8 of the paper is going to be shaded. Okay, Kamar?
I think 4/8.
All right, Kamara says she thinks 4/8 of the paper is going to be shaded. Let's see. Open your paper. How many parts do we have now?
8. 4/8.
No, now how many are shaded? How many parts are there? 8. Let's count them.
1, 2, 3, 4, 5, 6, 7, 8.
All right, does everybody have 8 parts?
Yes.
On their paper? Okay, now, how many parts are shaded?
4.
4. Very good job. You have 4 parts. Now we have 4 parts that are shaded. 4 out of how many parts are shaded?
8.
4 out of 8. So 4/8 of the paper is shaded. Okay. So, did the size of the paper change?
No.
What changed on the paper?
The parts.
The size of the parts. Did we shade in more once we changed the parts?
No.
No. So we took this model. We started off as a whole. We then folded into 1/2 and shaded 1/2. We folded again in half and we came up with 4 parts. We counted the shaded part. There was 2/4 of the part shaded. Then we folded again to make 8 parts. When we made our 8 parts, 4/8 of the paper was shaded. So what happens when you generate equivalent fractions using a model? What changes?
It gets smaller.
What gets smaller?
The parts.
The parts of the fraction get smaller. Are these fractions equal?
No, ma'am.
Yes.
Yes, ma'am.
Why? How do you know they're equal? Did we change this 1/2 that we colored the first time, that we shaded the first time?
No, ma'am.
No, we did not change the shaded amount. Axel, what are you going to say? Very good. The amount that we shaded to make 1/2 did not change. The only thing that changed was the number of parts. So 1/2 is equal to 2/4. We did not shade anymore. We still kept our shaded amount. We just made the parts what? Smaller. When we went from 2/4 to 4/8, did we change how many parts we had shaded?
No.
We started off with the same 1/2 that we shaded. What happened from 1/2 to 4/8?
They got bigger. They got
smaller.
You find it, did the parts get smaller or bigger? We went from 1/2 to 4/8. Are the parts smaller or bigger?
Smaller.
Very good. The parts got smaller. So we're going to learn how to generate equivalent fractions using models and using fraction bars. Okay, take your paper, fold it over. I'm going to pick them up. I'm coming around. So, in order to generate equivalent fractions using models, what do you have to do? Who can raise their hand and tell me? What do you have to do to generate equivalent fractions using models? What did we do? We took these models and we started off with one fraction. We started off 1/2. What did we do to generate fractions that were equivalent to 1/2? We broke the pieces down, but we broke the pieces down to what? Parts. Did the parts get smaller or did the parts get bigger?
Smaller.
Very good. We took these parts, bigger parts, and we broke them down to smaller parts. The amount that we shaded did not change. The size of the paper did not change. The only thing changed was the parts of the paper. Okay? Everybody understand? Any questions before we go on? All right, now I'm going to watch a video on generating equivalent fractions.
Whole pizza here. Let's say that I were to cut it into 2 equal pieces. So let me cut it right over here into 2 equal pieces. And let's say that I ate one of those 2 equal pieces. So let's say I ate all of this right over here. What fraction of the pizza have I eaten? Well, I took the whole and I divided it into 2 equal pieces, and then I ate one of those pieces. And then I ate one of those pieces. So I ate 1/2 of the pizza. Now let's imagine that instead of cutting that pizza into only 2 equal pieces, let's imagine instead that I decided to cut it into 4 equal pieces. So let's draw that. So 4 equal pieces. So I could cut it once this way, and then I could cut it once this way. And so here, I have 4 equal pieces. 4 equal pieces. But let's say that I want to eat the same amount of pizza. How many of these 4 equal pieces would I have to eat? I encourage you to pause the video and think about that. Well, I would eat this piece. You could imagine me eating this piece and this piece right over here. I've eaten the same amount of the pizza. Each of these pieces, you could imagine, got cut into 2 pieces when I cut the whole pizza this way. And so now I have to eat 2 slices of the 4 as opposed to 1 slice of the 2. So I just ate 2 out of the 4 slices.
Okay, let's look at the pizza. What happened to the 1/2 pizza?
So even though these...
Who can tell me? What happened to the 1/2 pizza to make 2 4? Laneriana? So he cut it from having 2 parts into how many parts? 4 parts. The parts got what? Smaller. Is the pizza size equal from 1/2 to 2 4? Yes. The only thing changed was the parts of the pizza. Okay?
I'm using different numbers here. Here I'm using a 1/2, and here, or 1 in the numerator, a 2 in the denominator. Here I'm using a 2 in the numerator, and a 4 in the denominator. These 2 fractions represent the same quantity. I ate the same amount of pizza. If I ate 2/4 of a pizza, if I eat 2 out of 4 equal pieces, that's the same fraction of the pizza as if I eat 1 out of 2 equal pieces. So we would say that these 2 things are equivalent fractions. Now let's do another one like this. Instead of just dividing into 4 equal pieces, let's divide it into 8 equal pieces. 8 equal pieces. So now we could cut once like this. So now we have 2 equal pieces. Cut once like this. Now we have 4 equal pieces. And then divide each of those 4 pieces into 2 pieces. So we'll cut those in. So here we have, so let's see. I want to make them equal pieces. Those don't look as equal as I would like. So that looks more equal. And then that looks reasonably equal. So now how many equal pieces do I have? I have 8 equal pieces. I have 8 equal pieces. But let's say I wanted to eat the same fraction of the pizza. So I could eat all of these pieces right over here. Well, how many of those 8 equal pieces have I eaten? Well, I've eaten 1, 2, 3, 4 of those 8 equal pieces. And so once again, this fraction, 4 of 8, or 4/8, is equivalent to 2/4, which is equivalent to 1/2. And you might see a little bit of a pattern here. Going from this scenario to this scenario, I got twice as many equal slices. Because I had twice as many equal slices, I needed to eat 2 times the number of slices.
So let's look at the pizza. We started off with a whole pizza. The pizza was broken up into what?
Half.
1/2. Very good job. We went from 1/2 to what?
2/4.
By making the parts what? Smaller. Okay? So, if me and Brian was going to eat pizza, and Brian, we split the pizza in half. Brian, you can eat 1/2 of the pizza. Okay? Brian decides that half of the pizza is too big. I want my slices to be smaller. So, if he cut the pizza into 4 parts, and he still eat half of the pizza, how many parts have he eaten? Instead of eating 1, he's eating 2 parts. Okay? What if Brian say, those 2 parts are just too big. I need my pizza smaller. I want to have more parts of the pizza. Okay? We cut the pizza into 8 parts. But Brian still ate the same amount of pizza. If the pizza is cut into 8 parts, how many parts of the pizza have Brian eaten now? 4 parts. 4/8. Okay? The fractions change, but they equal the same what?
Thing.
Not thing. Amount. Very good. They equal the same what?
Amount.
They equal the same amount. What changes on the fraction?
The parts.
The parts get smaller. The size of the pizza, the size of the paper did not change. The only thing changed was the parts. We made the parts smaller to generate equivalent fractions. Now I want you to use, you're gonna use fraction bars. You're gonna use them in groups. So whoever your partner is, your shoulder partner, you all are gonna use these fraction bars. Do not open them. You are going to work together. So that means that no one is in charge. It is a group effort. You are going to not fuss over the fraction bars. We're going to work together, okay? Everybody understand?
Yes, ma'am.
Okay, very good. Somebody in the group, I want you to take out the red long fraction bar. Everybody has it out? Okay, now what I want you to do, is take your fraction bars and empty them out and sort them by color. You have blue fraction bars, you have brown fraction bars. Do not place them on the ground, on the floor. Okay. All right, now, if we have a hole and we take that hole and cut it into half parts, how many half parts will we have? You see the blue fraction bars that says 1/2? Oh, y'all are going ahead of me. Okay, you see the blue that says 1/2? You're going to put them up under the hole. So we're going to go to smaller pieces. We're going to start out with one hole. Then we're going to go to 2 pieces, 2 parts, 3 parts, 4 parts, 5 parts, 6 parts, 8 parts, 10 parts, and 12 parts. So once you put your fraction bars together, it should look like this. You're going to start off with a hole, a half. Okay. No, you got, there's no knives. We break it up into half. We're going to break it up into 3 parts. Thirds. You're going to break it up into fourths. You're going to break it up into fifths. 6, 8 parts, 10 parts, and 12 parts. Okay, everybody about done? Your bag may have 8 pieces, that's okay. No, ma'am. We're gonna break it up into. We're not gonna break it up into 7 parts. We're gonna break it up into. Start with the whole. Break it up into 2 parts, 3 parts. Break it up into fifths. You're gonna break it up into 6 parts, 8 parts, 10ths, and 12. Ma'am? 8. Why is some out my bag? Okay. Does everybody have their fraction bars put together?
No, ma'am.
Okay, when your group is done, raise your hand. Good job, Brian, Riley. And put your hands in the air when your group was done. Go ahead and put them on top. Speed up, y'all. You should have 12. Okay. When you have your fraction bar put together, your fraction bar should look just like this, okay? What did the fraction bar start off with? One whole. It started off with one whole, okay? It went from one whole to what? Went from one whole to how many parts? Two parts. It went to two halves. One half. It went to two parts. We took it and cut it up into how many parts then? 3 parts. Then we cut it into how many parts? 4 parts. So the whole cut it into 4 parts. Once we finished, we ended up with how many parts of that whole? 12 parts. Okay. Everyone has this sheet of paper on their desk. And we're going to answer some questions using your fraction bars. Okay? As a group. All right. Read the first question for me, Jamarion.
How many 1/6 bars are equal to 1/2 bar?
All right, so let's look at our 1/6 bars. All right, everybody put your finger on your somebody in the group, put your finger on your 1/6 bars, okay? Then another person, put your finger on 1/2 of a bar, right on, go same corner that your partner is on, okay? Very good job. So, start on this side, because she's on this side. So you got to see it from this side. So you're going to have to maneuver around David. All right? Now, take out. So the question was, how many 1/6 bars are equivalent to 1/2? Okay? Remove 1/2 of your bar. Remove 1/2 of the 2-part bar. Okay? Not the 1/6. Take out 1/2. Alright, if you remove 1/2 of that bar, just say I remove this half of my bar. How many 1/6 is equal to that 1/2 of a bar?
3.
3 what?
3
6. 3 of the 1/6 is equal to 1/2 of the bar. So, it says how many 1/6 bars are equal to 1/2? How many was it, Kamari? 3. Very good job. So, your answer would be 3. How many 1/6 bars are equal to 1/2? 3 1/6 bars are equal to 1/2. 3 1/6 bars are equal what? 3. No, not 3.
3 bars.
If I had 3 of these 1/6 bars, 1/6, 1/6, 1/6, give me a total of how many 6? 3 6. So 1/2 is equal to how many 6 bars?
3
6 bars, okay? Very good job. Now, what I want you to do, I want you to do work